Examples come to section 2.6, the chain rule. We're given here in this example s equals 3t plus 1 over 2t minus 3, all raised to the exponent 7, and we're asked what's ds by dt. This would be another example of, okay, well, when I have something to the power of 7, the first part of my derivative is to say I have 7 times that to the 6th, and that is definitely where we start here. 7 times this expression to the 6th. But now I have to say multiplied by the derivative of the inside. Now, the derivative of the inside, you're going to have to remember what your quotient rule is, because it's certainly quotient rule, I think, is the easiest way to do this one. We have the bottom, 2t minus 3, times the derivative of the top, which is 3, minus the top, 3t plus 1, times the derivative of the bottom, divided by the bottom squared, 2t minus 3 squared. Now, that's a pretty terrible looking expression, but there are actually a lot of things here that will simplify to make it look a little bit better. Let's leave this first bit alone for a second. 7 times 3t plus 1 over 2t minus 3 to the 6th. But let's look at what happens inside the second bracket. We've got 6t minus 9 minus 6t minus 2, and then we have 2t minus 3 squared. Now, if you realize, first of all, collecting like terms in that piece is going to get rid of those t's. We'll just have negative 11 there. Negative 11 times 7 is negative 77. On the top we have this 3t plus 1 to the 6th, but if you look at the bottom we have 2t minus 3 to the 6th and then 2t minus 3 to the 2, so we can write this as 2t minus 3 to the 8. And that would be, as factored and as simplified as that one will get. It combines both knowledge of, well, obviously the power rule, but the chain rule, and also the quotient rule. So a good, tough derivative question. So this next one is a bit of a beastly polynomial here. We've got f of x equals x cubed plus 4, all in brackets squared, times 3 minus 4x, all in brackets to the 5th. Certainly we'll need the chain rule to deal with this, but we'll also use the product rule. And so we need to kind of be keeping track of both of those as we roll along here. So I have, maybe I'll say the first function, so x cubed plus 4 squared, times the derivative of the second. Now that's going to be 5 times this to the 4 times negative 4. Now, plus the second function, 3 minus 4x to the 5, times the derivative of the first, which is going to be 2 times x cubed plus 4 to the 1 times 3x squared. So there's a lot to keep track of there, of what you've differentiated and what you haven't. Now you can see why we spent so much time earlier in the semester factoring, if you can recognize the fact that you've got a lot of common factors here. For sure, just looking at the constants, this first one has negative 20, the next one has 6, and so I can at least take out a 2. I also have x cubed plus 4 common to both. First one has it squared, second one has it to the 1, so I take out the smaller of the two exponents. I have 3 minus 4x to the 4 and to the 5, so I'll take out to the exponent 4. Now, what do I have left over after I've common factored that? Well, I had negative 20, so I still have negative 10, since I took out a 2. I still have x cubed plus 4 to the 1, and other than that, the rest of that term is gone. Now, the next one I have plus, I took out the 2, so I have 3x squared, and the only thing left is 3 minus 4x. These first terms are fine, just leave them as they are. 2 times x cubed plus 4 times 3 minus 4x to the 4. But in these brackets here, for sure, I should have a look and see if I can simplify it a bit. Negative 10x to the 3 minus 40 plus 9x squared minus 12x to the 3. So if nothing else, at least I have some like terms there. So I have 2 times x cubed plus 4 times 3 minus 4x to the 4 times, and now what do I have here? Negative 22x to the 3 plus 9x squared minus 40. And we have an expression for the derivative. It required us to know our product rule for sure, but as well to know our chain rule to get there.